Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to continue with our fundamentals demo. And in this video, we're assuming that you've already gotten your P1 working so that you have access to the P1.C source file. Additionally, what I've done is I've created this fundamentals_demo project, and we will be using this one quite extensively over the next few videos. What I'd like to do is I'd like to leverage what you've done in P1.C so that you can sort of understand what we're going to be doing later on in our more advanced projects. Now, in our P1.C that you'll notice over on the right side, I basically put all of my code in main. Well, that's great, except that doesn't really give us a lot of flexibility in what our executable does. Ideally, what we'd like to have is an executable that can do multiple things, much like what you saw with the switches from the command line executables that we ran in an earlier video. To accomplish this, what I'd like to do is I'd like to take our information that we have told about ourselves and put it into a separate function that can then be called when we choose to call it. Now, we're not going to be handling any logic in this example or any switches yet, but we will very shortly. Instead, what I want to do is I want to focus, if you would, on the anatomy of our fundamentals.C. Our fundamentals.C is nothing more than a main.C that was renamed when I created the fundamentals demo project. The template from NetBeans has already been overwritten with the information from the main template that you should have downloaded, in which case you'll notice that I've also included the file information, which we are now going to change to fundamentals.c. The copyright is 2021, and then we are currently on version 1 with my initials and a quick comment about the version. This, of course, once again, is intended for testing purposes for some of the features in our demo. Now, going back to the P1.C, instead of directly copying all of our code into the main, what we would like to do now is we would like to have a separate function that can be called to essentially just print out the information about the user. So we'll get back to these includes in just a second, but what I'd like for you to do is add another line directly above directly below the includes. And these are going to be our function prototypes. And what you're going to see in C is that there's a three-step process to declaring a function. The first thing that you have to do is essentially declare the intent to have a function. You could sort of think of this as a contract, if you would, and that contract then can be followed up with later on. But the first thing is this prototype or contract. And what I'd like to do is I'd simply like to have this contract return an int, and I'm going to call this contract or this function getInfo, and it's going to accept no input arguments. And then we follow this with a semicolon. And so the idea is that this is simply going to print information about the user. Okay, so you could sort of think of this as an about function. So we could easily have called it that as well. The second step then is below our int main, we simply want to duplicate what we did in the function prototype minus the semicolon. So in this case, it's going to be int get_info void. But this time around, instead of the semicolon, we want to provide a set of curly braces. Now, the third thing that we want to do is we want to provide a return value. And for right now, what we're going to do is we're simply going to return the integer associated with exit underscore success. We'll delve into return values and why you would pick a specific return value later. But for right now, we're going to use the two constants, exit success and exit failure. These constants can be found by simply right-clicking on the exit underscore success and going to navigate and then going to the declaration and definition. If you do so, a second file should pop up, or rather another file should pop up called standardlib.h, and you will see that exit success is defined as 0. You can think of this as saying there were 0 errors. Exit failure is 1. As you get more and more sophisticated applications, you can have other constants associated with different types of errors. But how did we know to use exit success and exit failure? Or rather, where do they come from? Well, if you'll notice here, we have an include. An include is a part of a list of what are known as preprocessor directives. And what this does is this tells the compiler where additional code or where additional libraries can be found. And this is a great opportunity for you to pause the video and sort of explore a little bit about what all is possible in a C executable. We are going to only be using a few of the libraries that are provided with MinGW, but if you right-click and you go to declaration or definition, once again, you'll see a .h file pops up, which is, we will see later, is essentially a definition file. But more importantly, if you hover over that standard io.h, you will see the path to where it sits. And so if you see, in this case, it's C software, MinGW include. So what we want to do is, for just a second, let's go take a look what all is actually in that folder. So C software, MinGW include, and you will see there are a lot of .h files. One in which we will be definitely using later on is going to be the math.h. And you can guess that in the math.h are going to be things like sine and cosine and so on. As a matter of fact, if you scroll down a little bit, you'll see there is our beloved sine, cosine, tangent, and so on. But let's not get too distracted yet. Let's go back to our fundamentals.c and remember that the whole purpose was, how can we move the code from main into one of these functions? Well, what we're going to do is we're going to go over to our p1.c that we've highlighted. We can right-click and copy, or simply highlight and do Control-C. And then in our get info, we can paste the code. Now, this will compile. As a matter of fact, this is probably a great opportunity for us to test to make sure we haven't broken anything. And sure enough, we get a build successful. But more importantly, it doesn't do anything. Why doesn't it do anything? Well, if you remember earlier in the video, I said that this was part of a 3-step process. The first step is to declare the function prototype. That's essentially a contract that says, this is what we want to do. The second step is to write the contract. In other words, write the code for the function to do something. The third step is to actually call or to execute that contract. And to do that, we simply, in our main, type in get_info and with parentheses and a semicolon. And this calls our function. So remember, it's a 3-step process. First, we declare the contract or the intention to build a function. The second step is to write the function or write the code associated with the function. And then the third step is to actually call our function. Now, there's a whole number of reasons that we will use functions in the future, but the least, or not the least of which rather, is simply for code reuse. If you find yourself using the same code over and over and over again, it's probably a really good idea to encapsulate this or to wrap this into a function. We'll get plenty of opportunity to look at this in a little bit, but let's for right now see if this actually accomplishes anything. And so I'm going to go ahead and build it. I'm going to once again open up my command line by doing Windows R and typing in CMD. I'm going to CD to my documents, to courses, to EE233, to my projects folder. And this time what I want to do is I want to go to my fundamentals demo. And in my fundamentals demo, you'll see there's my fundamentals.c. I want to CD to my distribution, to my debug, min-gw folder, and then type in dir. And there, sure enough, is my fundamentals _demo.exe. And yes, I know it's a little long, but if you get used to hitting the tab and autocomplete, it will get pretty natural to you to be able to navigate these. But if I hit enter, you'll see the exact same output that you would have gotten in your P1. So once again, hopefully you found this video useful. Basically what we've done here is we have created our own function, moved the code out of main into that function, and then called that function from main. This is part of a larger concept known as top-down design and encapsulation. Also note here is this is our introduction to these preprocessor directives. We've actually seen a couple of them already. The include, which allows for us to include code that we have not necessarily written, but in this case borrowed from the standard IO and standard lib libraries. If you go to the standard IO or standard lib libraries, you've also seen another preprocessor directive called define. And that allows for us to define a constant of exit success or exit failure in this case. So once again, there's your second preprocessor directive. And then lastly, the idea of declaring or writing the prototype or the contract. About the only thing that we have left to do in this particular example is to simply add some documentation, in which case you want to go back to your main template, go ahead and borrow what I've given you, and finish this out. In this case, we're going to keep it pretty simple. The name of the function is just simply getInfo. The description prints out information about the author. And then the arguments, since there are no input arguments, you don't have to worry about that. You can just simply say returns an integer for success or failure. We'll get a little fancier later on. At this point, one last build just to make sure that we didn't break anything, and we're done. Hopefully you found this video useful. As always, if you've got any questions or comments, don't hesitate to email me. Thank you for watching.